Hello and welcome to my first chemistry video. My name's Chris and I'm a chemistry tutor, and I'm going to cover the topic of electrophilic addition. It's a mechanism, one that you have to do in AS chemistry. So I'm going to explain it in terms of as though it was just a live lesson. There is no editing, there is no fancy graphics if that's what you're into. I'm sorry it's not here. But hopefully it'll be helpful. Please let me know if it is by obviously clicking the like button. All right then, so let's start. The first thing is you need to know what a curly arrow is. A curly arrow means something very specific. It means the movement of a pair of electrons. So we'll say movement of two electrons. It doesn't mean anything else in chemistry. It's always two electrons, and it's always from a covalent bond, because of course this is organic chemistry, and organic chemistry is about carbon compounds. All right, let's look at a real mechanism. The reason we don't use straight arrows in mechanisms is because we use straight arrows for chemical reactions when we're saying it goes from here to here. A curly arrow just means that, a movement of a pair of electrons. So I'm going to start with a fairly reactive molecule, which is ethene. And we're going to add something to it, because of course this is addition. And what we're going to add to it is HBr. Now HBr is also a covalent molecule. All of these bonds are covalent, in other words, a shared pair of electrons. You probably taught at GCSE that the electrons are shared equally. That is not the case usually, because bromine is a lot more electronegative than hydrogen. If you're not sure which is which, bromine is at the right of the periodic table, and you should know that as you go further to the right of the periodic table, you get more attraction of electrons in the covalent bond. So get to the bottom of it. This is delta minus, and this is delta plus, because the bromine pulls the electrons in this covalent bond slightly towards itself. It doesn't gain an electron. Don't forget, one of these electrons is from bromine and the other one is from the hydrogen. It's now time to do our first curly arrow. This is an electrophile. And what an electrophile is, it's an electron pair acceptor. And that's exactly what it does. It accepts a pair of electrons, and the pair of electrons it's going to accept is two of the electrons from the double bond. And the electrons in the double bond, there are 4 of them. If we move electrons to here, they're going to repel these electrons towards the bromine. Now we can finish it off, and we can say that we're going to add a hydrogen to one of the carbon atoms because it's an addition reaction, and it doesn't matter which one we add it to because it's a symmetrical molecule. So what we're going to make is something called a Carbo-Cation. I wouldn't worry too much about that name. It's just a molecule with carbon in it that happens to have a positive charge, cation. Right. Sorry about that. Right, okay, that doesn't mean anything whatsoever. And also you're going to get bromine or bromide ions. This is now negative because it got back one of the electrons that it owned already, and it got an extra one. So it's got a negative charge. The charges always balance out. There were no charges on the left to start with. Now there's a charge here, so there must be a charge here. Now bromine has got a number of paired electrons. They're called lone pairs because they're not doing anything. Now, we only need one of those lone pairs, and in an exam question, I would suggest that you only draw one pair of electrons. All we're going to do now is make a covalent bond between the bromine and the carbon with the positive on it. Obviously, these electrons are going to be attracted to there. And our product, I'm not going to write out all the bonds. You should be able to switch between the two types of formulae. How many hydrogens have we got on there? We've only got 2. And we've got the bromine. And that is our first electrophilic addition reaction. Notice that the electrons repel each other whenever they can. There's still a lone pair on this, and I've just realized I've forgotten the carbon there, but never mind. It's right now. It's an addition reaction because there's only one product. If you ever see a reaction that only has one product, it means it must be an addition. It's not a substitution, which we'll cover in a later video. It's an addition, so there's no other products. Now, the next video, which I'm going to do, is going to feature things that are unsymmetrical. Because in this one, we've got an issue. There's only one hydrogen on there. And then we've got another carbon atom. And there's 3 hydrogens on that one. So as you can see, it's not symmetrical. And as we'll see in our next video, HBr, there's a lot of repetition in this, which is good because it means it's less for you to remember. There's not much to remember in organic chemistry once you understand the rules. So once again, we know what the dipole is, and if we didn't, we could work it out. But we've got a bit of a dilemma now. We don't know whether to put the hydrogen on this carbon or this one. We can't put it on this one because there's no double bond near it. Right, so what we're going to do is this. And again, the bromine can add to either, the hydrogen can add to either this carbon or this one. So in the next video, I'm going to show what actually happens. So we'll leave it there for this one, but in the next one, we'll look at electrophilic addition again, but this time to asymmetrical alkenes. And that will be quite a short video because there isn't a great deal to it. I hope this has been helpful. If it has, please press the like button or click it. And I hope to see you in the next one. Thank you very much for watching. Bye.